Yes, good morning. My name is Recep Özkan, and our work is multi-class prediction of occupational accident types using XGBoost in pipeline construction. Firstly, our motivation, why safety in pipeline construction? Because construction has the highest count on fatal work injuries of any private industry, and pipeline construction, one of its highest subsectors, remains understudied for data-driven accident prediction. For example, 20% of all occupational deaths occur in construction, and almost 3 million workers die yearly from work accident and diseases, and 30 and 40% of fatal injuries in construction sector, but only 7% of global employment in construction is very high. Why pipeline hazard? Pipeline construction is the special construction because pressure and fire explosion and chemical exposure is very common in pipeline sector. Our research gave most of works predicts accidents and severity of or risk level. This is a reactive and a post-incident view of how bad an outcome was, and answers how severe, not what will happen, and limited guidance for targeted prevention. But in this study, we predict the accident type directly, and this is a proactive approach and anticipates the kind of event before it occurs, and enable targeted training, planning, and resource allocation. And we use root and immediate causes as inputs and type as the target. Our objective, we apply a multi-class XGBoost model to predict 6 occupational accident types in pipeline construction, and this is filling a clear gap in the safety prediction literature because pipeline is very has a small literature. And machine learning for construction safety, machine learning and AI models increasingly support proactive safety management and uncovering complex cause, effects, and patterns that traditional statistics. For example, Mehmetov et al. Use machine learning across 12 pipeline site data set, and they predict accident outcomes, and this is for our work methodological basis. And you et al. Use multi-class model for 9 accident types, but this is not pipeline sector. And another works use machine learning and AI in construction sector. This is our data set. We use over 5,000 unstructured field reports, and we obtain 1,184 structured accident records. And this project include real data from Asia to Europe cross-border pipeline project, and we use 6 event classes. These are bodily reaction and exertion, and contact with object and equipments, and exposure to harmful substance, and falls, fires, and explosion, and transportational accident. These are our input feature. We use time block, for example, morning, afternoon, evening, night, and seasons, weekday, and fatality, injury, and product damage, and near missing accident. And we use immediate causes and root causes. And these are our preprocessing pipeline. Firstly, all fields numerical encoded, and these separate categorical text feature mapped, and missing records removed, and we supplied 80% and 20% train test data. These are methodology. We use XGBoost and SMOD for imbalanced multi-class data. Why XGBoost? Because these are regularized gradient boosting, and this is overfitting, and second order gradients more accurate optimization, and sparsity aware and endless missing values natively, and scalable and strong on structured tabular data. Okay, and we handle class imbalance. It's small, applied only to train set to prevent data leakage. And these are our results. We obtain 83% accuracy across 6 extant classes, and our macro average F1 is 0.82. We can see separately for classes. Here, strong performance, class 4, 3, and 0, 5. These are a strong performance, but main weakness, class 1. These are contact with object and equipment. Frequently, it's misclassified as class 3. These are false. Cause, shade cause, and similar cause with the false. And contribution and limitation, these are proactive, not reactive, and actionable for practice, and works on real data. And our limitation, we use SMOD. These are a little bit synthetic samples, and scope of classes only 6 type, and needs live validation maybe on construction side. In conclusion, XGBoost predicted 6 pipeline construction extant types with 83% accuracy and 82% macro F1. And key takeaways, type prediction gives more actionable guidelines, severity prediction, and automated classification on incidence reports for safety teams, and links route codes to specific extent types for weather planning, and for future work, maybe larger and more diverse pipeline data set or other machine learning algorithms can be used, or test transfer across construction subsectors, and deploy live integrated with BIM or IoT-based monitoring. Thank you for listening.
Thank you very much.
Thank you.